Video 23, Inequalities with Multiplication and Division. For tonight's video, I recommend that you watch it straight through once, then play it a second time, and only copy the two inequality examples that you see in the video. It's not necessary for you to copy the equations. Then complete your two you try it's and bring those in to class tomorrow. Let's get started. What is an inequality? An inequality, if you remember, is a comparison of two expressions. We have an expression on the left side of the inequality symbol, comparison symbol, and an expression on the right side. So we're comparing the two. We're not stating that they're equal. We're stating that one is possibly less than the other one for this example. 4 times a number is less than negative 24. Notice the difference between is less than and less than. Is less than is an inequality. It's a sentence, two expressions being compared. Less than alone is your switch phrase for subtraction. So make sure you realize the difference having that word is makes. Okay? How do we solve inequalities? We will solve it just like you do an equation. So when we looked at the equation 4x equals negative 24, we asked ourselves what operation is happening? Well, that's multiplication, of course. What is the inverse operation of multiplication? That's division. Same thing with our inequality. This is multiplication, and the inverse that we would perform is division. So let's do that. So we're going to divide both sides by 4 for both the equation and for the inequality. When we do that, we realize that for the equation, x equals negative 6. For the inequality, we find out that x is anything less than negative 6. So every possible number less than negative 6 would make this inequality true. What's the difference between an equation and an inequality? Well, an equation has only one answer, one correct answer, one correct solution. But an inequality has an unlimited number of answers. It's impossible to list them all, so we graph them on a number line. Okay, so let's graph the inequality we just solved. 4x is less than negative 24. After dividing both sides by 4, we realize that x is anything less than negative 6. Okay, step 1, draw yourself a number line. Step 2, put 0 and your calculated value on the number line. So we're going to put 0 and negative 6 on this number line. Step 3, we're going to put a circle on the calculated value. Okay, so we have a circle to identify our calculated value. For the symbols less than or greater than, we're going to leave that circle unshaded. We have a less than, so we're leaving the circle unshaded. The calculated value is not a solution. Negative 6 is not less than negative 6. So negative 6 is not one of our solutions. If the symbol had been less than or equal to or greater than or equal to, we would shade the circle and the calculated value would be a solution. But for this example, our calculated value is not a solution. Step 4, we're going to shade to the left if it's less than, values less than, we will shade to the left. If we have a greater than symbol, we're going to shade to the right, meaning we need only solutions that are greater than our calculated value. So we're going to grab a crayon so that we can shade in this situation. Whoops. Oh man. Crazy program. In this situation, we're going to shade to the left because we need everything less than negative 6. That's our correct answer. Okay, so looking at this, here's our solution set. On the number line, we show that everything less than -6 is a possible solution. So some of our solutions are -7, -8, and -9 because they fall in this shaded section of the graph. Even decimals would work. -7.4, -8.99, -9.001, and so on. Also, fractions would work as solutions. -7.5, -8 3/5. We're missing a negative sign there. And also -10 2/3. Okay. -6, however, is not a solution. It's not shaded, so it's not a solution. Also, -5, -4, and -3 are not solutions. They fall in this non-shaded side of our number line. 0 and all the positive numbers are also not solutions because they too fall in the unshaded side of our number line. Okay, let's try another one. This time a division. Notice I have the division equation, a number divided by 3 equals -4, and a similar inequality, a number divided by 3 is greater than or equal to -4. First question you should ask yourself, what operation is happening? Division. What is the inverse operation? Multiplication. So let's multiply both sides by 3 for the equation and for the inequality. They're worked the same way. When we do that, we realize that for the equation, m is equal to -12, one solution, but for the inequality, m is greater than or equal to -12. We have lots of solutions. Okay, so let's graph our inequality. Step 1, draw our number line. Step 2, put 0 and the calculated value on the number line. Step 3, put a circle on our calculated value. And remember, if it's less than or greater than, we're going to leave that circle unshaded. The calculated value would not be a solution. But for this example, we have a greater than or equal to. So for less than or equal to or greater than or equal to, we do shade the circle. So notice -12 is a solution. Then step 4 says we're going to shade to the left if it was less than, to the right if it was greater than. Ours is greater than or equal to, so we need to grab ourselves a crayon and we're going to shade to the right. We want everything greater than or equal to -12. Okay, so now stop the video, watch it again, taking notes on just the inequalities and the graphs, the number lines for those solutions, and then try these two yourself. Bring those into class tomorrow and we will go over them.